Hello, this is Ian McTavish. I'm the founding mentor of Team 4152 Hoya Robotics in Huntsville, Ontario. This is the third in our video series, and this video is taking the sketch that we created, the two-dimensional sketch, and we're going to transform that into a part and start assembling our gearbox. So we're in the part studio, and here's the sketch. The first thing is that we need to find our motor. So we're using the mini sim motor, and Vex Robotics has lots of details. Andy Mark is another supplier where you can get these things. In the Vex Robotics website, I really like their drawings. It's easy to find the information I need. So with this motor, we're going to need to mount it. So here we can see there's a 2-inch circle, and on both sides of that 2-inch circle there are 2 holes, and those holes are 0.159 inches in diameter. The pinion as well, it's going to need to fit. This is the shaft part, and you can see that that's 0.75 inches. So those are the critical dimensions that we need to be able to access. So in the part studio, we need to double click that sketch, and we're going to use that. The key thing is we're reusing the sketch because we want to be able to use these construction circles to set everything up. First thing that we're going to do is we're going to create a vertical line. So there's my line tool. It's going to be a construction line, and I'm just holding it over, and I want to highlight, make sure that nothing is going orange, because that indicates that it's constrained in some way. So I'm just going to do it here, and I've got a nice vertical line, and that line I'm going to set to 2 inches. So with creating lines, you click the first point, you move the mouse, click a second point, and I made sure to hold my mouse so that this little vertical constraint icon showed up. Once you've clicked twice, then you just type the dimensions that you're dealing with, and you're good to go. And all my dimensions are in inches. That was set in the first video. Now, I'm going to add a constraint to this. I'm going to select my midpoint, and I'm going to select the line, and I'm going to select this point right there. And because my mini sim is going to go in this location, and so I'm going to have another thing there. So here's my second line. So this is the same idea, but this one is going to be horizontal. Again, it's 2 inches. And if you notice, when you hold your mouse over things, you can see shortcuts that will help you out. So there's my midpoint, and that's going to be here. So now that I've got those in position, I'm going to be adding these circles. So basically 0.159, if I do 13/64, then we can use a 13/64 drill bit to drill through those, and that should be more than enough space for a 1032 bit. And you can see that it's a 1032 machine screw that they use for this. So center point circle, and I just make sure I'm on the point, and because I'm doing a 13/64, I can actually just type 13/64 and enter, and that's 0.203 inches, but it does the math for me. I don't need to worry about it. So I just made a bit of a mistake there, and that's okay. When you make a mistake, you just fix it. So I just need to see where my measurement went. So yeah, I don't need 13 inches. I'm just going to copy that measurement so I can quickly do this. I could also use the equals constraint. So I'm just going to escape, and I'll show you what I mean. There's the equals constraint, and that way I can constrain these circles to be exactly the same diameter, which is, when you have multiple circles the same diameter, that's a great strategy, because it just, you make one change and everything will change. So I've got those all set up. Now I need a circle that's going to go right there, and this circle is going to be 0.75 inches, so that the gear and the pinion will fit right through. The gear and the shaft of the motor will fit right through there. So 2 of these. You'll notice these are solid black, so that means they will become holes when I move on, which is great. Now, right here, these are where my gears are, so I'm going to have a shaft go through there, and basically I'm going to have a flanged bearing. So I can look through here, and there's hardware, there's bearings in Vex Robotics, and I'm looking for 0.5 inch diameter. So these are my flange bearings. So there we go. So that's the part number, and I can look in my drawing. And so the diameter of my hole needs to be 1.125. So I want it just a little bit bigger than what they've got so that I can put the bearing in, and it's not so big that the bearing's just going to move around, but it's nice and snug and it will fit. So I'm going to create a circle there, and it's 1.125. And I'm going to have a bearing where this gear is for the shaft there, 1.125. Now, my sketch is complete. I can click my green check mark, and there's my sketch. Everything's in good shape. Now I'm going to extrude this. So I'm just going to click the extrude button and click the sketch. And the bonus is, because I clicked in the rectangle, it will make that solid, but it will leave holes wherever I have those circles. So I don't need to do much work to do that. And 0.125. Now, the one thing is, I'm going to go back into my sketch. You'll notice that this circle is going to extend, so I'm just going to change that to 9 inches. Now, the only problem is, because I've centered it on the origin, everything is going to stretch symmetrically, which for my tutorial, I don't really care. That's fine. Now, down here, I've got a part. Really important that we name things as we go. And so I'm renaming my extrude, and I'm going to go into properties, and I'm going to name my part. So part 1 is useless. We can have hundreds of parts in a robot, and if they're all called part 1, it's very hard to figure out what's going on. So I'm going to call this gearbox plate, which is pretty descriptive. I'm going to give a description in it, so in a year or two when I go, oh, I want to redo that, but what was the gear ratio? I know exactly what it was, and I would fill that in. If you watch the slideshow, everything's there. And this follows the naming conventions that we talked about in the previous video. So this is my very first part, so that's why it's part 1. Save that, and now that part's got a name. I can right click and I can assign a material, and it's really important to assign a material because then it will assign a weight so that you know how much the material weighs. So I'm going to use aluminum 6061, and for gearbox plates we use either aluminum or Lexan, and the thickness depends on the type of gearbox. So the last thing that I want to just highlight is I can edit the appearance of this. And for metal parts, I just stick with this color, but I can set the alpha transparency, and that's really useful when you've got a complex assembly and you want to be able to kind of see through some parts to be able to see where things line up and everything. So I'm not changing anything there. I just wanted to point that out. And that concludes that step. We now have a 3-dimensional part, and that 3-dimensional part, in the next video, we're going to start assembling our gearbox using that.